following definition is extremely important for reasons that will soon emerge. Let's let A and B both be n by n matrices. So they're square matrices of the same dimension. Then definition, A and B are called similar if there is some third matrix P such that A equals P inverse times B times P. Let's make a few observations. First of all, it doesn't matter where the inverse goes in this definition. You could just as easily have it over here. So if we let W be P inverse, then A equals W times B times W inverse. So if you look for help online or something, and you see the inverse over here to the right, instead of over here to the left, it doesn't matter. This definition is the same whether you have the inverse here or the inverse here. Second, it may look like A and B are playing fundamentally different roles in this definition, but that's not true. If A equals P inverse times B times P, then B equals P times A times P inverse. Multiply both sides of this equation on the left by P to cancel this, and on the right by P inverse to cancel this, and we're left with that. And similar, if we wanted to write to the inverse on the other side, well, B equals P inverse times A times P. So if we can write A as an inverse times B times a matrix, we can write B as an inverse times A times a matrix. A and B are interchangeable in this definition.